Hello, welcome to 5 Minute Math. Today we're going to talk about trig functions. One of the things I want to uh, let you know is that a trig function are those funny words that you see on a scientific calculator or a graphing calculator. They talk about the proportions of the sides in a right triangle of any kind of given angle. Now, every angle has a specific proportionality to it. So if I made a random triangle and said that this was 40 degrees, the sine of 40 degrees, no matter how big this triangle is, it could be this small, it could be this huge, 40 degrees. Both of them is the sine of this angle, the proportion of the sides of the triangles are always going to be the exact same thing. And the reason we want to be able to use these is because oftentimes you can find the sides of a missing triangle. You can use it to figure out how long you're going to need a certain piece of lumber, for example, if you're building a bridge, for instance. So right triangles are very, very important, and so are trig functions. They're very helpful in helping you figure certain things out. So let's start by talking about sine, cosine, and tangent. Whenever you're given an angle theta, the side that's opposite, that means the side that's not touching the angle, is called the opposite side. I labeled it A. The side that's adjacent, which is the leg that touches the angle, is called, I labeled that B. And the hypotenuse, which is the longest line in a right triangle, is called C. Sine would be the opposite over the hypotenuse, A over C. Cosine is the adjacent over hypotenuse, B over C. And tangent is the opposite over adjacent, which is A over B. Now secant, cosecant, and cotangent are inverses of sine, cosine, and tangent. These two are inverses, so instead of opposite over adjacent, it's really the adjacent over the opposite. The cosine and secant are inverses of each other. So instead of opposite over or adjacent over hypotenuse, it's hypotenuse over adjacent. And finally, the sine and the cosecant are inverses of each other. So instead of the opposite over the hypotenuse, it is the hypotenuse over the opposite. That being said, there's two triangles that you want to remember because most students taking trig are probably going to be asked to use or apply the unit circle. The first triangle is this one. It's the what we call the 45 45 90 triangle. 45 45 90, and the other one is a very poorly drawn 30 60 90 triangle. In a 45 45 90 triangle, if the legs were 1, the hypotenuse is radical 2. And you'll see why I do this in a bit. And in a 30 60 90 triangle, if this side here is 1, the hypotenuse is 2, and the longer leg is the square root of 3, radical 3. And you can easily derive that from the Pythagorean theorem, but we're not going to be talking about that particularly right now. So let's begin. Let's pretend on my unit circle here that I drew this line, which is a radius, and I labeled this 30 degrees. Because it's called a unit circle, the length of this line here, the hypotenuse is 1. That also means that instead of using the 30, 60, 90 triangle like I would normally, 1 radical 3, 2, I actually have to change the sides in order to fit the unit circle. So because the hypotenuse went from 2 to 1, I'm going to divide both the legs by 2. So my shortest side is now 1/2, and my longer leg is now radical 3 over 2. That actually makes sine, cosine, tangent pretty easy. The sine of 30 degrees of 30 degrees is equals to 1/2. Sine of 30 equals to 1/2. It's just the opposite side, basically. Sine 30 equals to 1/2. The cosine of 30 is radical 3 over 2. And the reason for that is because, remember, the cosine was what? It's the adjacent over the hypotenuse. So radical 3 over 2 over 1 equals to radical 3 over 2. Nothing changes. And the tangent equals to 1 over radical 3. Now, when we're talking about the unit circle, you also need to remember that this entire circle encompasses a whole 360 degrees. So we're not limited to just 30, 60, and 90. We're also or 30, 60, and 90, or 45. We also are able to go 30, 45, 60 past every one of these quadrants, I guess. So this 9 here denotes 90 degrees. This here is 0 degrees. This is 180 degrees. And this is a 270 degrees. This is important because if I wanted to, say, for example, find the cosine of 135 degrees, I can still do it. I can still find the cosine of 135 degrees. By noting that the angle created here is what? This is actually a 45-degree angle. So if I have a 45-degree angle here, and I can find the cosine of this triangle right here, it's essentially the same as trying to find the cosine of 135 degrees. So let's label the sides again. I have 1, and this is radical 2, and this is radical 2, square root of 2, and square root of 2. Let's find the cosine. Negative square root of 2. The cosine of 135 degrees is actually going to be negative radical 2. And the reason it's negative is because we're in the second quadrant here. The bottom line here is going to be negative because we're in the second quadrant. And this vertical line is going to be positive because we're in the second quadrant. This is also true if we were to move into the third quadrant. If we move into the third quadrant, draw another line. Now let's use green. If we draw yet another line, let's say it's 60 past right here, then if I drop the hypotenuse, or drop the right angle, and this was 60 past, I can say that this angle right here is 180 plus 60, that would be 240. So this is 240 degrees. So if I wanted to find the sine of 240 degrees, I just have to pretend this is a 30, 60, 90 triangle. This would be 30, that would be 60, and this here is 90. So let's remember our sides again. The sides would be 1/2 and radical 3 over 2. Except because we're in the second quadrant, this line is actually negative 1/2, and this line right here is actually negative 3, radical 3 over 2. So the cosine of 240 degrees is the opposite, negative radical 3 over 2 over the hypotenuse, which is 1. So cosine of 240 degrees equals to radical 3 over 2. And that's how we use the unit circle. You can use, if you don't have a calculator on hand and you're asked to find a sine, cosine, tangent of certain degrees, and usually if you're a student in math, you will be starting with the basic degrees, 30, 60, and 90. You can very quickly figure out what it is as long as you can remember this triangle and the side measurements, and this triangle and the side measurements. Then it's just a matter of knowing what your trig functions do. This has been probably longer than 5-minute math. Hope you enjoyed. Please rate and comment.